case of oxyacetylene gas welding, the oxygen is stored inside a cylinder at a very high pressure of approx 15 megapascal, so that its specific volume is reduced and we can store large volume of oxygen inside. This reduction of specific volume is required because oxygen has very large specific volume. Now, the specific volume is the number of cubic meters occupied by 1 kilogram of matter. It is the ratio of a material's volume to its mass, which is same as the reciprocal of its density. In other words, we can say that specific volume is inversely proportional to density. Now, since acetylene is highly reactive, it is stored inside a cylinder in absorbed form with acetone. It remains absorbed in acetone, and at 1.5 megapascal, 1 liter of acetone can absorb up to 400 liters of C2H2. To connect the oxygen cylinder to the torch body, which is the equipment for welding, copper hoses will be used because of their good strength and flexibility. But acetylene or C2H2 is highly reactive and can decompose copper, and hence copper is not used for making hoses or pathway for acetylene. Instead, rubber is used. Since both the cylinder add hoses and there are various number of cylinders placed in a plant or workplace, there are chances of cross connection which may lead to severe accident. And hence, to avoid this, different color codes are used in respective hoses. Black or blue color is for oxygen gas and the material used is copper. Red or maroon color is for acetylene gas and the material used here is rubber. Now, the reaction that you can see here is what is going on inside the mixing chamber, which is an integrated part of the torch body. Here, for complete burning or combustion of 1 mole of acetylene, 2.5 moles of oxygen is needed. So, 1 mole of C2H2 for fully combustion needs 2.5 mole of oxygen. Here, 1 mole of oxygen is from the cylinder and 1.5 mole of oxygen is taken from the atmosphere. If less than 1 mole of oxygen is taken from the cylinder, the resulting flame that we get is a carburizing flame. If 1 mole of oxygen is taken from the cylinder, exactly 1 mole, then the flame that we are getting is called neutral flame. And if more than 1 mole of oxygen is taken from the cylinder, the resulting flame is oxidizing flame. Whatsoever quantity of oxygen is taken from the cylinder, the rest is taken from the atmosphere to complete the 2.5 mole of oxygen, which is required for the complete combustion of 1 mole of acetylene.